Welcome, Mr. Sutton here, bringing you the Pre-Cal Honors 3-3 Extra Practice Number 3 solutions on adding and subtracting rational functions. To combine these rational expressions by subtracting, we must first get a common denominator. So we're going to do this in two parts. Let me look at the coefficients first, the 4, the 5, and the 2. So let's see here. We've got 5. That's the biggest of them. Now, does 4 go into 5? No, it doesn't. What's the smallest number that 4 and 5 both go into? Well, that would be 20. Does 2 go into 20? It does. So 20 is the LCD between our coefficients. And now we also know that we're going to need a q as one of those factors too. Just a single q, because there's at most one q in each of these denominators. So now we're going to multiply each fraction by whatever it needs to give us this LCD. For our first fraction, we have to multiply by 5 to get 20q, so 5 over 5, because we're really just multiplying by 1 here, not changing the value of anything. For the second fraction, we have to multiply that by 4 over 4 to get 20q. And this last fraction, that gets multiplied by 10 over 10. Actually multiplying those out, we've got 15 over 20q minus 8 over 20q minus, this will be 10 over 20q. Since we have the same denominator, we know we're going to end up with one fraction with a denominator of 20q, the LCD. But now let's subtract the numerators. 15 minus 8, that's going to be 7. And 7 minus 10, that gives us negative 3. So then, negative 3 over 20q. To simplify this rational expression, since we're subtracting, we need a common denominator. To see what that is, I need to factor each of these denominators. So the first one looks like I can take out a 4. That leaves me with x minus 4. For this next one, I can take out a 9, leaving me with an x minus 4 again there. So taking a look at my LCD, let's deal with the 4 and the 9 first. What's the smallest number 4 and 9 both go into? Let's see. Well, multiples of 9, we've got 9, 18, 27. 4 doesn't go into any of those. 36, though. 36 works for both 9 and 4. So we have 36, and then we need an x minus 4 as well, and just a single x minus 4 because there's at most one of those in each denominator. So now let's multiply each fraction by what it needs to give us this LCD. For the first fraction, we've already got the x minus 4. To turn 4 into 36, we need to multiply by 9 over 9. And here we're just really multiplying by 1, so not changing the value, just making it look a little different. For the second fraction, which we are subtracting, we've got the x minus 4. 9 needs to be 36, so we'll multiply by 4 over 4 to get that. Multiplying this out now, for the first fraction, 6 times 9, that's 54 in the numerator. And we have 36 parentheses x minus 4 in the denominator, which was kind of what we were hoping for. We were trying to get the LCD down there, but it's always good to check. For this next fraction, 3 times 4 is 12, so we have minus 12 over, and again we get 36 and x minus 4. Since I have the same denominator, I have just one fraction now that I can create with that denominator, and now I'm actually just going to subtract the numerators. So 54 minus 12, that's going to be 42. And let's just double check. Can I reduce 42 and 36? Well, it turns out I can. Those are both divisible by 6. So reducing that, we've got a 7 and a 6 that those turn into. So when the dust settles, we end up with 7 over 6 parentheses x minus 4. For this problem, to simplify, we need to get a common denominator, and we're almost there. If you look at these denominators, one is just the other with the signs reversed. So one thing I'm going to do is I'm actually going to factor this second one here. To get this to have a y minus 8, I just have to take a negative 1 out of this bottom right denominator. So if I do that, I end up with a negative 8 and a positive y, which is to say a y minus 8 you could write it as. And we see here that we don't quite have a common denominator, but we're very close. So there's two ways you could go at this point. One is you could multiply this first fraction by negative 1 over negative 1. But there's actually a faster way. This negative here and this negative actually cancel out. So you can just write 7 over y minus 8 plus 6 over y minus 8. That's another way of getting rid of that negative 1 rather than trying to make the other fraction have a negative 1. And at this point, we do have a common denominator. So we can just add these together, keep the denominator, and just add the numerators. 7 plus 6 is 13. And it doesn't look like there's anything else we can do to simplify or reduce, so this one's done. To simplify this one by subtracting, I need to get a common denominator. And before I can do that, I need to factor this bottom right here so that I can see what I'm dealing with for factors. So I need factors of negative 28 that add up to negative 3. So we got 1 and 28 doesn't work, 2 and 14 is no good. 4 and 7 is the only one left, and that one's going to work if I have positive 4 and negative 7. So I've got x plus 4, x minus 7. And now that I've listed out these factors, I can see exactly what I need in my LCD. So I'll definitely need an x plus 4 for that x plus 4 there, and also an x minus 7, and that covers this other x minus 7 as well. So now let me just multiply this first fraction by whatever it needs to get the LCD. So we've already got the x minus 7. We need an x plus 4. So I'll multiply by x plus 4 over itself. Totally legal, because I'm really just multiplying by 1, so not actually changing the value. And then this other fraction, well, it's actually already perfect the way it is. We already have the LCD down there, so there's, if it ain't broke, don't fix it. All right, let's multiply this first fraction out now to simplify it a little bit. So I've got, in the numerator here, I have to distribute that 5, so that's 5 times x, 5x, and then 5 times 4 gives us a plus 20. In the denominator, we should have x plus 4 and x minus 7. That's the LCD that we were trying to get. And the second fraction here, don't forget that. That's still hanging around. Don't need to do anything new with it, though. At this point, since we have the same denominator, we can combine these into one big fraction over the LCD. And in the numerator then, subtracting now, we're going to have a 5x. There's nothing to combine that with. But we also have a 20 minus 55, which is negative 35. And now that we've combined our fractions, we should always double check to see if we can factor and reduce. It looks like we can factor, so if I take out a 5 from the numerator, that leaves me with an x minus 7. And it does look like we can cancel those x minus 7s. Whoops, let's try that again. X minus 7s cancel. There we go. So now that we've done that, we have a 5 over x plus 4 that we did not cancel out. And can't get any better than that, so we are done. To simplify this expression, since I'm subtracting, I need a common denominator. So let's see here. Let's deal with the 4 and the 6 first. What's the smallest number that 4 and 6 both go into? Well, that would be 12, so we need a 12 in the LCD. We also need an x for that factor and a y squared for that y squared. And now I just need to multiply each fraction by whatever it needs to give us this LCD. So the first fraction, we've already got the y squared. We need to multiply by an x. And to get 4 to be a 12, we need to multiply by 3. So that would be 3x over 3x. Again, we do the number over itself so that we're actually multiplying by 1 and not changing the value. For the next fraction, I have the x already. I need a y squared. And to get 6 to be 12, I need to multiply by 2. So 2y squared over itself. Multiplying all this out now, we have 3x times 3x, that's 9x squared, over our LCD of 12xy squared. For this next one, we've got minus and then y times 2y squared, that's going to be 2y cubed. Still have the LCD in the denominator of that one, but it's always good to double check. Since I have the same denominator, now I can just merge those into one fraction over 12xy squared. And then we have 9x squared minus 2y cubed up there. Since those are not like terms, I can't combine them. I'm just going to have to leave them this way. It doesn't look like I can factor and do any kind of canceling otherwise either. So this one is done.